This lecture is talking about polarity. How do you know if a molecule is polar or not? The thing is that you can't determine if a molecule is polar without a correct Lewis structure. So don't assume that the molecule is polar or nonpolar just by looking at the formula. For example, chlorine triiodide might look like it's nonpolar since it has 3 iodines around a central atom, so you might think it was trigonal planar. But if you do the Lewis structure, you'll see that it isn't. It is asymmetrical and polar. So always, if you're asked about whether a molecule is polar, you need to look at the Lewis structure. If the molecule is completely symmetrical, you can stop right here. It is definitely nonpolar. So if you look at these examples, all of the outer atoms are the same. They're all X's. And there are no lone pairs on the central Y. Because they are symmetrical, they are nonpolar. When you're looking for symmetrical, you can ignore any multiple bonds. For example, the two on the left, where you've got X, Y2, both would have the same polarity. They are symmetric. If you assume that these are examples of legal Lewis structures, they're all symmetrical and therefore nonpolar. The two on the right are also symmetrical. It doesn't matter that one has one double bond and the other has 2 double bonds. It is still considered symmetrical. All of the outer atoms are the same, and there are no lone pairs on the central atom. So, an asymmetrical molecule is polar. What you're looking for is a molecule with non-identical outer atoms, a non-symmetrical linear molecule, one or more lone pairs on the central atom, or a diatomic molecule with a polar bond. Diatomic means it has 2 atoms in it. Let's look at some examples. These molecules are asymmetrical because outer atoms are different. They're not all the same. So as long as, for example, Z and X have different electronegativities, the molecule will be polar. The thing is that I'm not going to trick you with this. I will set it up so that Z and X have different electronegativity so you can count on the molecule being polar. So if you have different outer atoms, as long as the electronegativities are different, the molecule will be polar. Anything which has a lone pair on the central atom, consider it as polar. Again, I'm not going to trick you with this. If they have lone pairs, they will be polar. However, there are 2 exceptions, which I'll show you later. What about diatomic molecules? This is a diatomic molecule. If the bond is polar, the molecule is polar. How do you know if the bond is polar? You look at the difference in electronegativity between Y and X. So, you use the electronegativity table and you subtract the 2 values. If the difference is 0.4 or less, the bond is nonpolar. If it's between 0.5 and 1.9, it's polar, and if it's 2.0 or greater, then the bond is considered ionic. There are 2 exceptions to the lone pair on the central atom rule. If the molecule is square planar, meaning it has 4 bond pairs and 2 lone pairs with the same outer atoms, it would be nonpolar. And if you construct a molecule in your head, you might be able to see that. It's just a square with an electron pair on the top and on the bottom. Also, if the molecule is linear with 2 bond pairs and 3 lone pairs and has identical outer atoms, then it is going to be nonpolar. And you might run into that situation.